Welcome back to Future Tech Unlocked. In the last few videos, we talked about microservices, what they are, how they're different from monoliths, and how they talk to each other. Now that we've laid the foundation, it's time to take things a step further. Because once you have a bunch of microservices up and running, the next big challenge is scaling them. Scaling isn't just about handling more traffic. It's about making sure your system stays fast, reliable, and efficient as it grows. Whether you're building something small that might grow over time, or you're already dealing with thousands of users, understanding how to scale microservices properly is key to building systems that last. In this video, we're going to explore what it really means to scale microservices, why it matters, and some common patterns and tools that help teams do it effectively. First things first, what is scaling? Let's start with the basics. Scaling simply means making your system capable of handling more load. That could be more users, more data, or more requests, without things slowing down or crashing. Think of it as preparing your system to grow without breaking a sweat dot. Now, here's where microservices really shine. In a traditional monolithic application, if one part of the system is struggling, say Amazon's recommendation engine, you'd often have to scale the entire application just to keep things running smoothly. That's not only inefficient, but also expensive and hard to manage. With microservices, we get to scale smartly. Each component is independent, so you can scale just the parts that are actually under pressure. Let's say you're running an online store. Your payment service might only be called once per transaction, but your product recommendation service is getting hit constantly as users scroll, click, and explore products. Instead of throwing more resources at the whole system, you can just scale up the recommendation service. This targeted approach saves cost, improves performance, and gives you way more flexibility as your system grows. Alright, so now that we're diving into scaling microservices, the first thing you need to know is that there are two main ways to scale a system, and understanding the difference between them is super important. First, we have the vertical scaling, as known as scale-up. Imagine you have a laptop that's starting to lag because you're running too many apps. What do? You upgrade it, maybe throw in more RAM, or swap your hard drive for a faster SSD. That's what vertical scaling is. You're beefing up the same machine to handle more load. Now this works fine for a while, but there's a catch. You can only upgrade so much. Eventually, it gets really expensive, or you hit a limit, like this server already has the best CPU we can afford. So yeah, useful, but not super flexible for long-term growth. Whereas on the other hand, we have horizontal scaling, also known as scale-out. Now this is where microservices really flex their muscles. Now this is where microservices get cool. Instead of upgrading one server, you just add more of them. Like instead of one super-powered fare service, you have 10 smaller ones, all doing the same job, sharing the load. So if Uber's ride-matching service is getting overloaded during peak hours, they don't panic and upgrade a big machine. Nope. They just spin up more instances of that service. 5, 10, 20. Whatever's needed to keep things running smooth. And the best part, they only scale the services that are under pressure. They don't touch the rest. Now that we know horizontal scaling is the real MVP when it comes to handling big loads, how do companies like Uber actually do it without everything turning into chaos? Let me walk you through some of the coolest and smartest strategies they use. Load balancing. Imagine Uber has, say, 5 instances of their login service running. When you log into the app, your request could go to any one of them. But we don't want all the users piling into a single server while the others are just chilling, right? That's where a load balancer comes in. It's like a traffic cop at a 5-lane intersection. It directs incoming requests to whichever instance has the most breathing room. So instead of one server burning out, the load balancer keeps traffic smooth and balanced. Everyone gets a fast response, and the system stays healthy. Tools like Nginx and AWS Elastic Load Balancer make this happen. Okay, now imagine it's Friday night and everyone is opening Uber, trying to book rides, check prices, track drivers. The whole system's under pressure. You don't want someone sitting there manually spinning up more instances. That's where auto-scaling steps in. With platforms like AWS, Google Cloud, or Azure, the system is watching key signals like high CPU usage, memory thresholds, increased number of requests. When it sees things heating up, It automatically adds more instances. And when traffic drops, it scales down to save money. It's like cruise control, but for your cloud infrastructure. Uber likely uses this to handle city-specific traffic spikes, like during rush hour in New York versus a quieter evening in a smaller town. Next, let's look at another main strategy that works hand in hand with scaling microservices, and that's caching. Think of caching like the brain's short-term memory. Instead of doing the same hard work over and over again, we just remember the answer for a little while so we can serve it faster next time. Imagine you open Facebook and scroll through your feed. Now multiply that by billions of users checking their feeds every few minutes. Without caching, every scroll would mean fetching fresh data from the database, posts, comments, likes, all in real time. That's way too much pressure on the back end. Instead, Facebook uses caching to temporarily store things like your news feed, profile data, or recently viewed posts. So when you scroll down or refresh your feed, a lot of that info is already waiting for you in cache. No need to hit the main database every single time. Tools like Memcached and TAO, which Facebook actually built in-house, help make this happen behind the scenes. They handle millions of requests per second and make the platform feel snappy. So in short, caching is like reusing the answers to questions that are asked often, instead of making the system do all the work every time. It saves processing power, reduces server load, and makes everything run faster for the end user. Simple, right? For more details, please check out my earlier video on unlocking the secrets of system design. Caching, strategies, and real-world examples explained. Okay, so let's dive into another powerful scaling strategy, database sharding. Think about how much data Facebook has to deal with every second. Billions of users, countless messages, tons of photos and videos, status updates, likes, comments. Now imagine trying to store all of that in just one massive database. Sounds wild, right? That database would be so huge and overloaded that even the simplest action, like checking your notifications, could take forever. And that's where database sharding comes to the rescue. Instead of using one gigantic database, Facebook shards its data, meaning they split it into multiple, smaller databases based on some kind of logic. For example, one shard might handle user data starting from A to F, another for G to M, another for N to Z, or even more advanced, sharding by user ID, geography, or activity level. So when you log in and scroll through your feed, Facebook doesn't need to go through a mountain of unrelated data. It goes straight to your shard and serves up your info in milliseconds. It's like Facebook is running a global library, and instead of putting every book ever written into a single room, they split the collection across different sections, sorted by topics or authors. That way, when you want a specific book, the system knows exactly where to go. And as Facebook keeps growing, they can just add more shards, like building more bookshelves when the library gets bigger. So in a nutshell, database sharding helps Facebook scale effortlessly, keeping everything lightning fast, organized, and always available, even with billions of users online at once. Pretty smart, right? If you want to dive deeper into this topic, I've already covered a detailed video on sharding. And while you're at it, don't miss my earlier video on unlocking the secrets of system design, load balancing, and database sharding explained. Another key piece in the system design puzzle. So the next time you're using an app that works flawlessly, even when millions of people are online, just remember, behind the scenes, someone's done an incredible job designing their microservices to scale like a pro. What should we dive into next? Let me know in the comments. I'd love to hear your thoughts. And hey, if you enjoyed this video, don't forget to like, subscribe, and share it with your fellow tech enthusiasts. The more the merrier, right? Catch you in the next one.